Hey guys, this is Civil Learning Online and this is 8th lecture on project management. In this video, I am going to discuss about the computation of pod network, in which we will learn to calculate the earliest expected time, latest allowable time, slack and the critical path. I have given a brief introduction about this topic in the previous video. Link is in the description. You can go and watch those videos and then come to this video. And without any further delay, let's get started. So guys, let's begin our today's lecture, in which I will show you how to calculate the earliest expected time, latest allowable time, slack and the critical path of this given network. And the question says a network is shown below. It is talking about this network which is here, with the expected time of completion of each activity. As in the previous video I have already told you that small t e represents the expected time for the completion of that activity, which is computed once we know the optimistic time, pessimistic time and the most likely time. And further the question says determine the earliest expected time and the latest occurrence time for each event. Now we are asked to calculate the earliest expected time and the latest occurrence time for each event, and we will further calculate slack and the critical path. And I have already discussed about the meaning of slack and the critical path in the previous video. You can have the link for the previous video in the description. So just for revision, I would like to make you familiar with some term once again, and they are predecessor event, successor event, slack and the critical path. So talking about the predecessor event are those events which are to be completed prior to start any other event. Means until and unless we have completed first that event, that particular event, we cannot move to the further event. The such events are called predecessor event. For example, here if we talk about event 2, event 1 is predecessor event of this event 2, because until and unless event 1 is completed, we cannot start event 2. That's why it is called predecessor event in with respect to event 2. 1 is predecessor event with respect to 2. Similarly, successor event are those events which starts one and only after the predecessor event is completed. Means here 2 is successor of event 1. Similarly, 5 and 7 is successor of event 2. These events are called successor event. Now slack is nothing but the difference between the latest allowable occurrence time and the earliest expected time. As well as critical path are the longest path in the project network, which I have already mentioned in the previous video. And we will also learn how to which is the critical path in this diagram. So let's without wasting time, let's dive into the numerical. And for that I will show you first how to calculate the earliest expected time and the latest allowable time on this diagram, and later we will it is sometimes asked in exam to calculate the earliest expected time and the latest allowable time in a tabular form. So I will show you how to do that also. First let us first calculate the earliest expected time and the latest allowable time in this diagram. So as I already told you in the previous video that earliest expected time in the first event is taken as 0. So here we will write it as TE equals to 0. Now I have also mentioned that the earliest expected time will be maximum of all the events when there is a complex network. So we will begin with TE equals to 0. Now we also know that TE of the successor event will be given by TE of 2. Event 2 will be equals to 0 plus 5 will be equals to 5. Similarly, TE of this 3, event 3 will be equals to 0 plus 6 will be equals to 6. Now here TE of 4, TE equals to 6 plus 2 will be equals to 8. Similarly, here TE of event 5, here we have for 5 there are 2 predecessor event, one is 2 and one is 4. So here we will have 2 EEs and we will take one of those maximum. So 5 plus 4 is 9, 5 plus 4 is 9. Similarly 8 plus 5 is 13, and maximum of both these two will be the earliest expected time of event 5. I have mentioned you the reason in the previous lecture, and that was we cannot move further until the particular event is completed. Suppose we are to complete this event 5, we cannot come to the event 5 until and unless event 2 and event 4 are completed. And in order to complete that, we will require the maximum time, because both should be completed. Here if we move to event 5 from 4, it requires 13 days suppose, and if we move to event 5 from 2 to 5, it is going to require 9 days. So if we take only 9 days, then our we haven't still completed the event 4. That's why we'll take the maximum expected time. We will cross this and take it as 13. Earliest expected time of event 5 will be 13. Now after this, what we do, we will move further. So earliest expected time of event 6, TE of 6. Now see here guys, we have 13 plus 8. 13 plus 8 is going to be 21. Similarly 8 plus 7, because 4 is predecessor of this event 6. So 8 plus 7 is going to be 15. Now maximum among these two is 21. So earliest expected time of event 6 is 21. So cross this. Now we will need to calculate the earliest expected time of event 7. So TE of 7, here 7 has two predecessors, they are 2 and 6. So 5 plus 6 is 11. 2 to 7, 5 plus 6 is 11. Here we have 21 plus 3 is 24. Now come here to event 8. So we have here 8 plus 6 is going to be 14. So now we have to 11 and 24, maximum of these two is 24. So 24 will be here. Now TE of 9. So TE of 9 is going to be, I have missed to provide the expected time of this event 6 to 9. So let me write it here. So expected time from event of activity 6 to 9 is 3. We need to calculate the earliest expected time of event 9. So it is going to be 24 plus 9 is going to be 29, comma, there are 3 predecessors. So here we will have 3 earliest expected time. So 21 plus 3 is 24 and 14 plus 4 is 18, and maximum of these two is 29. So the earliest expected time of event 9 is 29. Now we need to calculate the latest allowable time. So latest allowable time, what we do, as I already told you, that latest allowable time is equal to the schedule time for completion of the schedule, which is denoted by TS. So TS equals to TL equals to, we will take the same time period as TL. So it is going to be 29. TL is going to be 29 of event 9. Now 29 minus 4, because in latest allowable time we do minus. So 29 minus 4 is going to be TL equals to 29 minus 4 is going to be 25. If you ask me to write the formula, then in the previous video I have shown you the formula for calculation of the earliest expected time and the latest allowable time, which were TE equals to TE of earlier event I plus TE IJ, duration. IJ indicates duration and TE is earliest expected time of the preceding event. Similarly, TL equals to TLJ minus TE IJ. Now TL of event 4. So subtract here, we will have 25 minus 6 is going to be 19. Similarly, here it has three successor events. So here it will have 3 TLs. So we have got one from here. Now one will come from here and one will come from here. So now here we have TL equals to 29 minus 3 is going to be 26. Similarly, 29 minus 5 is going to be 24. 24 minus 3. Now we are moving backward of this arrow. While calculating the earliest expected time, we will moving forward along the arrow. Now we are moving backward from the arrow. So 29 minus 5 was 24. TL of this 7 was 24. 24 minus 3. 24 minus 3 is 21. Similarly, here 6 has two successors, so minimum of these two is 21. So cross this 26 and TL of 6 is 21. Now 24 minus 6. 24 minus 6 is going to be 18. So TL of this event 2 is 18. Similarly, this 21 minus 8. TL equals to 21 minus 8 is going to be 13. So here 13. Now 13 minus 5. 13 minus 5 is going to be 8. Similarly, this 21 minus 7. 21 minus 7 is going to be 14. And the least among these three is 8. So TL of event 4 is 8. Now 8 minus 2. 8 minus 2. TL of event 3 is 6. 8 minus 2 is 6. Now 6 minus 6. 6 minus 6 is 0. So TL of event 1 is 6 minus 6 equals to 0, and 1 will be from here. So TL of event 2 is 18. So 18 minus 5. 18 minus 5 is 13, and the minimum of all these two is 0. So TL of event 1 is 0. And also slack. Slack equals to TL minus TE. So now once we have calculated here TL and TE, you can easily find out slack. Simply subtract TL minus TE, you will get some value, and that will be our slack. And using those slack, we will be able to determine the critical path. Minimum value of the slack will be the critical path of the given network. And I am going to show you in the tabular, that in the tabular form, and you can solve if you are not told to find it in tabular form, then you can solve it as it is, and you can easily calculate the slack also. Here you can write it below. If you ask me to do here, show you here, then we will write as slack S equals to 29 minus 29 is 0. Similarly, slack here is 25 minus 14. 25 minus 14 is 11. That's how we calculate the slack in a given network. So now I am going to show you in the tabular form. So here is a table. Simply pause the video and try solving the numerical as I am doing in this video. So pause the video and draw a table for you. So here is the table, and we will need this diagram in order to solve this numerical. So here we will begin with event 1. And talking about the event 1, there is no any predecessor event, so we will simply dash. There is no duration. So and this is E, and TE of this event 1 is 0. Similarly, event 1 has two successors, 2 and 3. So we will write both here. Successor event of event 1 is 2 and 3. It has no predecessor, so we simply write here dash, but here it has two successors, so 2 and 3. And the duration of 1 to 2 is 5, and 1 to 3 is 6. So 5 and 6. 5 and 6. Now after event 1, we will move to event 2 and write it here event 2. And event 2 has one successor, so we will write it here 1. And the duration of 1 to 2 is 5, so we will write here 5, this 5 here. And the TE of event 1, we will take TE of event 1 because here predecessor event is 1, so TE of 1 is 0, so 0 plus 5 is 5, and we will take it as here is no any extra predecessors, so this is the maximum value, so we will take TE equals to 5. And the successor of event 2, here successor of event 2 are 5 and 7, so we will write it here 5 and 7, and the duration of 5 and 7 is 4 and 6 respectively. So 5 duration of 5 event 5 is 4 and 6. Now draw a line here. Now move toward event 3. Event 3 has one predecessor and one successor. Predecessor is 1, successor is 4. So event 3, predecessor is 1 and successor is 4, and the duration is 6 and 2. So duration is 6 and 2. Now we need to calculate the earliest expected time of event 3. So earliest expected time of event 3 is going to be earliest expected time of this successor event, that is 0 plus 6. 0 plus 6 is going to be 6. This is maximum because there are no any other predecessors. So we will take TE of 3 equals to 6, and we have already written the duration. We will talk about these tables later. Once we have we first compute the value of earliest expected time, then we will move to that. Now it's the time for event 4. Event 4, and event 4 has one predecessor and 3 successor. 5, 6 and 8 are successor of event 4 and 3 is predecessor. So 3 is predecessor and successor are 5, 6 and 8. So 5, 6 and 8, and draw horizontal lines. Talking about durations, the durations from 4 to 3 was 2, so here it is 2. Similarly 5 duration is 5, 6 duration is 7 and 8 duration is 6. Now we need to add the earliest expected time of event 3, that is 6 plus 2 is 8 here, and this is maximum value, so this is 8. Now to move to event 5. Event 5. Event 5, talking about event 5, there are two predecessors 2 and 4. So there are two predecessors 2 and 4. Duration of 2 and 4, duration of 2 and 4 is 4 and 5. You can see here that is 4 and 5. So we will write it here as 4 and 5 respectively. Now successor of event 5 is 6, only 1, so here we go, and duration of 6 is 8, so write it here. Now we need to calculate the earliest expected time of event 5, and that is going to be, we have 2, so 5 plus 4 is going to be 9 and 4, 8. Earliest expected time is 8. 8 plus 5 is going to be 13, and maximum among these two is 13. So earliest expected time of event 5 is going to be 13, and draw a line. Now let's talk about event 6. Event 6 has two predecessors, that are 5 and 4, and two successors 7 and 9. So 5 and 4 predecessor events are event 6. Event 6 predecessor events are 5 and 4. So here we are going to write 5 and 4. Similarly successor of event 6, successor of event 6 is 7 and 9. So we will write here in successor column, that is 7 and 9. Similarly duration, that is 3 and 3. So we will write here duration 3 and 3. Similarly the durations here are 7 and 5 and 4. 5 and 4. Duration are 8 and 7. So we will write here 8 and 7. Now do the addition here. So 13 plus 8 is going to be here, 13 plus 8 is going to be 21 and 4. 8 plus 7 is going to be 15. Maximum is 21. So earliest expected time of event 6 is going to be 21. Now close this column, row. Now talking about the predecessor of event 7, there are two predecessors, that is 2 and 6. So 2 and 6, and the duration of these events are 6 and 3. So 6 and 3, and successor of event 7 is only 1, that is 9. So we will write it here in the column of successor, that is 9, and the duration is 5. So here we go 5. Now do the addition. We have event 2 and earliest expected time of event 2 is 5. So 5 plus 6 is going to be 11. so write it here 11, and 6, earliest expected time of event 6 is 21 plus 3 is 24, maximum is 24, so earliest expected time of event 7 is 24. Now talking about event 8, event 8 has one predecessor and one successor, 4 and 9, one predecessor that is 4, one successor that is 9, and the duration is 6 and 4, so 6 and 4. Now we have event 4, so earliest expected time of event 4 is 8, 8 plus 6 is going to be 14, and earliest expected time of event 8 is going to be 14 because it is maximum, there are no any extra predecessors of event 8. Now we will move to event 9. Event 9, I hope it is visible to you. Event 9 has three predecessors that are 7, 6 and 8, 7, 6 and 8. So we will write all these three predecessors, that is 7, 6 and 8. Now duration of these events are 5, 3 and 8, sorry 5, 3 and 4. You can see here 5, 3 and 4. So we will write it here as 5, 3 and 4. And successor of event 9, there is no any successor, so simply we will draw a dash here. And on doing addition, that is earliest expected time of event 7 is 9, 9 plus 5, 9 plus 5 is going to be 14. Similarly, earliest expected time of event 6 is 21, 21 plus 3 is going to be 24, and earliest expected time of event 8 is 14, so 14 plus 4 is going to be 18. A little bit mistake I have done here, that is earliest expected time of event 7 is 24, 24 plus 5 is going to be 29, and 24 and 18, these are correct now, and maximum among these three is going to be earliest expected time of event 9, that is 29 is the earliest expected time of event 9. And what we do now, let me draw the column rows here. Now we have finished calculating the earliest expected time. Now it's time to calculate the latest allowable time, and for latest allowable time what we do, we will take the same value, that is earliest expected time of the final event as the latest allowable time. So here we got 29, so it is going to be 29, and latest allowable time, this is successor event is 9, so what we need to do is latest allowable time of event 8 will be equals to 29 minus this duration. 29 minus this duration is 25. We will take least value for latest allowable time, that is 25. Now for event 7 also, here the successor event is 9 and the duration is 29, so 29 minus 5 is going to be 24, and 24 is the latest allowable time of event 7. Now for latest allowable time of event 6, there are two successors 7 and 9. So for calculating the latest allowable time of event 6 with respect to successor event 7, that is going to be 24 minus 3 is going to be 21, and with respect to event 9 is 29. Here we see 29, 29 minus 3 is going to be 26, and list of both is going to be latest allowable time, that is 21. So here we go, that is 21. Now for event 5 we have event 6 as successor, and the latest allowable time of event 6 is 21, so 21 minus 8 is going to be 13. Now here there are three successor of event 4 that are 5, 6 and 8. So we will take the latest allowable time of these events. First of all, let's take the event latest allowable time of event 5, that is 13. 13 minus 5 is going to be 8. Similarly, latest allowable time of event 6, event 6 is 21. 21 minus 7 is going to be 14, and latest allowable time of event 8, event 8 is 25. 25 minus 6 is going to be 19. List of all is 8, so latest allowable time of event 4 is 8. Now latest allowable time of event 3, here we have successor event as 4,
So 8 minus 2 is going to be 6, and latest allowable time of event 3 is going to be 6. Similarly, for event 2 there are two successor 5 and 7, and duration are 4 and 6. Latest allowable time of event 5 is 13, so 13 minus 4 is going to be 9. Latest allowable time of event 7 is 24, 24 minus 6 is going to be 18, list is 9, so latest allowable time of this event is 2 is 9. Now latest allowable time of event 1, latest allowable time of event 1 is, how we calculate, latest allowable time of event 5 and 6, 13 minus 5, 13 minus 5 is going to be 8. Similarly, of event 3 it is 6, so 6 minus 6 is going to be 0, and list of these two is 0. So this is how we calculate the latest allowable time of the given numerical. And now it's time to calculate the slack. So let me draw a column here, that is slack equals to TL minus TE. Now what we do, we will simply subtract these two values, TE from TL. So here we will get 0, 4, 0, 0, 0, 0, 0, 11 and 0. Now close this row and column. Finished. Now we have successfully calculated the slack of the given project. Now the critical path is going to be 1. What I said, all the value which has least value will be our critical path, will represent critical path. First 0 is 1, so let me write here 1. Second is 3, even 3 has 0, so 3. Then 4, 5, 6, 7, 4, 5, 6, 7, 3, 4, 5, 6, 7, and then finally we have 9. Here 9 has 0 slack, so 9. This is our critical path. Now what we do, in order to, so if we are asked to find the critical path, then whenever such type of question is asked in exam, what we do, we need to highlight these path, these value carrying the all the events which are lying in this number will be highlighted. So from 1 to 3, highlight this 1 to 3, it is going to represent our critical path here in this numerical. 1 to 3, then 3 to 4, 3 to 4, here we go, highlight the arrow head also. Now 4 to 5, 4 to 5, and again we have 5 to 6, 5 to 6, then we have 6 to 7, so 6 to 7, and finally we have 8, 7 to 9, 7 to 9. So this is our critical path of the given problem. See you in the next video, and I hope this video was very helpful to you. If you guys find this video very informative, then do like this video and share this video with your friend. See you in the next video. Till then, stay safe and take care of yourself, and do not forget to subscribe Civil Learning on our channel if you do not want to miss any updates.